is it not working? Oh, it is working. Oh, it's frozen. Yeah. Okay. All right. We're looking at composition of functions. It's also your report card. Get that signed for extra credit. And we're flying through this. We're not flying through it, but we're starting right now because we're going to see the play, the Mary Poppins play. Okay. Composition of functions. We're learning two things here. We're learning how to take two functions and compose them within each other, and then we're learning how to go the reverse direction with it, decompose. You're used to, I give you a function, and then I ask you to plug a number in, right? That's what you're used to doing. Same concept, but instead of plugging a number in, you're going to take in a whole nother function and plug it in. So it's very similar to the whole x plus h thing, because you're taking like a block expression and you're plugging it in, and then you have to clean it up. Okay? So let's start simple. First, you need to know the notation for when you're being asked to compose. It is called function composition because you're composing one within the other. The notation looks like this. It looks like it says fog. It does not say fog. It says f of g of x, which sounds repetitive, but it means that you're taking the innermost function g of x and you're substituting it in to f, is what it means. Here's another way to write it, where you literally see the function that is getting plugged in is in the inside. So g is getting plugged into f. So two ways to see it. You need to know both. This one to me is self-explanatory. G is on the inside. This one to me, the way I remember it, it means write the function f, then plug g in. That's the way I read that in order to know how to do it. Domain is going to come up. You see right here it says domain of g and g of x is in the domain of f. Domain is going to come up because if you're taking two functions and you're doing anything with them, if there are domain restrictions in either one of them, it's going to come up in whatever you do with them, right? So recall that from the 2-2 homework. All right, so let's make some notes. This means write f first, plug g in. That's what that means. So come down here. This is where it might help you with those highlighters. You've got F, and then you've got G. And if you need one of my highlighters, I have them right here. Anybody? Okay. Two different colors or just one? Two colors or one? Two? You're lucky. Anyone else? Are you raising? I couldn't tell. All right. So we have 4 things to find. Guys, remind yourself that when it says of x, right here, let's maybe make a little note. When it says of x, it means your final answer should be showing x in it. Okay? So this means answer has X. I'm trying to think of what's the shortest thing to write here. But it means that when you're done with the problem and you're looking at your answer, you should see X's in it. You never plugged numbers in. Now here, what does this mean? This means the answer is a number. Because they're saying plug 7 in, right? So the answer is a number. It is not going to be just X. We are plugging 7 in. Okay? Let's see. We have A, B. Did I copy it to the next? I did. Yeah. Your paper has a repeat slide. The next slide, I just copied all of that over because we're going to run out of room. Do you see that? So we're going to do A and B on this one, and then we'll do C and D on the next one. Okay, so let's label it. Here's A. We're finding F of G of X. Okay, so this means, this is how you read it. It means write the function f first. All right, 2x minus 5. And I'm going to color coordinate. Write the function f. There it is. Now you're going to beep out the x. So repeat this, but you're going to put a big old beep where there's an x. So 2 beep minus 5. And then in here, you're putting, it says G. Put G of X on the inside. So that's X squared minus 3X plus 8. And let me color coordinate. And now, that is it. That's all it is. But you do have to clean it up. So, setting it up is the hardest part. Then it's just a matter of your Algebra 2 skills with cleaning it up. We're going to distribute the 2 to just the stuff in the parentheses. Notice the negative 5 does not get multiplied by 2. Then we're going to combine those like terms at the end. Okay, notice it says now find G of F. I'm just going to come over here because there's not going to be any room over there. So I'm going to come right here and not B. What is it? G of F. G of F of X, which means your final answer should have X in it. So read the directions, or read the direction that it's written. Write function G first. So that's X squared minus 3X plus 8. Now, beep out the X. Everywhere there's an X. So, beep, squared minus 3 beep, plus 8. And then what goes in there? 2x minus 5 goes in there. And then now you have to clean it up. Be careful. Two x minus 5 raised to the second power is not 4x squared plus 25. It is not. That is a binomial. There's a subtraction sign there. That means there's two terms, which means this has to be multiplied out with the first, outer, inner, last rule, okay? So there's actually 3 terms here. So I don't know if you want to go somewhere else on your paper and find it, or you just want to come up underneath it and find it. But this would be 2x minus 5 times 2x minus 5. I'm just going to do it underneath, and then I'll bring the rest down. So first times first, outside, inside, and last. And then now you can see that this is minus 20x in the middle. Now, that's not the final answer. That was me just finding that binomial squared, right? Right here where I was finding the binomial squared, where I was writing it out, I'm going to go back and distribute this negative 3 to these. I'm just going to write it right here. That's minus 6x plus 15, bring down to plus 8, right? So this was me finding that binomial. Now, are there any like terms? So 4x squared, if it helps, I'll try to bring it down. Minus 6x, let's see, that's plus 23. Minus 6x plus 23. Now it's all in one line. Right? What combines? You got 4x squared minus 26x plus 48. I'm going to highlight in yellow that this right here was this math, which then became this right here, so that you know where that came from. The new part was the very first step, plugging it in. The rest of it is what you already know how to do, which is just your simplifying Algebra 2 steps. All right, we have enough room to fit B on here. You might wonder why. Look at what B asks for. What's it say? It says plug in 7, right? It says the exact same thing. It says go find f of g, then plug 7 in. Didn't we find f of g? And then go find g of f, then plug 7 in. Didn't we find g of f? Okay, so I'm going to come right here and write b. F of g of 7 would be the 2x squared minus 6x plus 11, right? Because that was f of g of x. Same problem. Plug 7 everywhere in you see x. So you want to type that in your calculator. You get 67. I'm going to come right here underneath this and put g of f of 7. What'd you get on this one? 60 what? 2? Okay, question. What if it was functions that you had not already calculated f of g of x and g of f of x? Okay? Make a note. Come over here. put B and then put in big letters dot dot dot, or like, had we not calculated the f of g and the g of f, how would you do it? Because you don't want to go through all of this if you don't have to, right? You know the goal is just to plug 7 in. So there's no reason to clean it all up and run the risk of making mistakes when all you really needed to do was plug 7 in. So let me show you using f of g. If I had said find f of g of 7, start with the innermost first, find g of 7. So you would go to the function g and you would plug what in your calculator? You would plug 7 in. And if you do that, you get 36. G of 7 is 36. I really wish I had more room right here. Equals 36. Then you take 36 and now you're going to plug it in to F. Yes. And if you do that, you should get 67. Oh, yeah. I think you're good. Yeah, now you take 36 and you can plug that in to F. It is way easier. The only reason we did it this way was because we had already found the expressions. A test-taking strategy is if you're worried your expression, your algebra here might have made a mistake, I would go that route if I asked you to evaluate a number in it. Let me make a note. Then find f of 37.
Why couldn't you just plug in 7 on both?
Or not 37, it was 36. Because you're embedding one within the other. You're not necessarily finding the two and like adding them together. It's not, yeah. Because that would be f plus g, not f of g. So, okay, that was A and B. Go to the next slide. And let's do C and D. You do C on your own. So we've already done A and B. Now we're doing C.
So in the x squared, the uniform is the whole entire equation in x.
Reword your question.
Like how it,
You're looking at this one, right?
Yes.
Okay, go.
So you're doing g of g, so then you do.
But read the end of it.
With 1.
Okay.
So are you just writing it out and just changing the x to a 1?
Yes.
Okay. Yeah. I didn't know if you had to like put the entire equation since it's of g of g.
When you plug 1 in, you'll be using the whole equation. Yeah. So because this says of a number, our answer should be what? A number. Go back to what that little tip was on the last one where I said, find. I'm going to change colors here so it stands out. Find the innermost part first, because that's the one that's your input, right? So find g of 1 first. So g of 1 means I'm going to function g, and everywhere there's an x, I'm putting 1. And what do you get? 6. So g of 1 is 6. Okay, now, color coordinate, let me go to, now you're going to do that second, you're now taking what you just found. You found g of 1 to be 6. So take that and now find whatever this letter is of that answer. Now find g of 6. Heard it. Yep. Now let me make sure, I'm going to point up here, so make sure your eyes are watching where I'm pointing. It says find g of 1. Okay, your mind should think, okay, so my answer is just a number. And the way you need to start this is the innermost, the input, which is just g of 1. So go to g, plug 1 in. What did you get? 6. Carry it down and carry this letter down. Now find the outermost one of the answer you got here. So g of 6 is 26. So that's the answer, 26. Y'all try D. Okay, f of f. So, of x, right? This means our answer should have x in it. You're not plugging numbers in. This means it's a block within a block, and then you just got to clean it up. Okay, so write function f first. 2x minus 5. Now beep out the x. So 2 beep minus 5. And you might want to make a note here, you know, what we're doing. We are beeping out x. That's what we're doing here, because then we go right back in and we plug this in, which is a repeat of 2x minus 5. And then now you clean it up. So that's the answer, but you got to clean it up. So 4x minus 10, bring down the minus 5. So 4x minus 15. Right? All right, how do you feel? Not bad? Don't you like when it's just algebra?
Well, guess what? Here comes domain.
It's all right. It's fine. It's going to be good. It's all fine. All right, look at the next one. You already know how to do A and, A, yeah. I was going to say A and B, but A has 2 parts. That's what I meant. Find the 2 parts for A. There's quite a bit to write here, so don't write too big. Find f of g of x here, then come over here and find g of f of x.
I'll write it in the next slide.
We're on the slide that says example 2. Which one are you on?
But that's what I write all the
Oh, it was here. So that one we were just on? No, wait. It was here. That slide here got repeated because there wasn't enough room. Do you need another set of notes? Are you sure? All right, f of g means write function f first. What is function f? Square root of x. Okay, now, what do we do? The next line, we wrote it. Beep out the x, right? So, square root of beep. Yes? It's going to feel weird. Maybe even make a note again. Let me draw an arrow or thing. Beep out x. That's how we got that. If you need to leave it there, then go to the next line and write where you plug it in. I don't know. Something to help you understand that you write the first function, then you beep out the x, then you plug the next one in. Okay? Is there anything to clean up? That's the answer. Now come over here. Write what first? G, which is x minus 3. Next, beep out the x, so beep minus 3. This is me. I'm just going to write in big letters. Beep. Next line, what goes there? The square root of x goes in the beep. Be very careful because thank you. The minus 3 is not under the radical here. Totally different. This is also to show you that the order of function composition matters. Okay, so those are the answers for A. The next part says, find the domain of f of g and g of f. This is the new part, which is really technically not new because it's what you did on those 3 14-part questions yesterday. So I'm going to come right here. G. We're talking about domain, right? If we are discussing the domain of f of g and g of f, we need to know the domain of just f and of just g before we can talk about composing them. So make a note. Find domain of f and g first, like by themselves. Okay, so what was the function f? I'm just copying it. It was the square root of x. What was the function g? It was x minus 3, right? Okay, I told you there's only 2 types of functions that have domain restrictions. One of them is fractions, where there's a variable in the bottom, and the other one is square roots. Function f is a square root, which means you have to stop, hold the phone, wait a minute, think about it. What's not allowed under a square root? Negative, which means it can be 0 and stay positive. So to get the domain of any square root, pull the radicand out. In this case, the radicand is just x, so it looks weird when I'm about to write. Maybe make a note. It's the radicand greater than or equal to 0 every time. The radicand is x. So that greater than or equal to 0, there's nothing to solve. So there is your domain restriction on f, right? So let's make a note. Little number line. I'm going to put a 0, and it's closed, and it's going this way. Correct? Would you agree? All right. What's the domain restriction on G? Look at what whenever I ask domain restriction, all you have to ask yourself is what type of function is it? What type of function is G? It's linear. There's no restriction. So this is, yep, which means all real numbers. So this one's going to be helpful. This is going to be the problem, this one. So G is going to be helpful. Okay, so now we're going to, I wrote kind of big. I'll do this. There we go. So we found just F and just G. Now we're going to find the domain of F of G and the domain of G of F. Let's make a note. The input of the composition is included in the domain. Write it and then I'll explain what you just wrote. Just write it and I'll explain it. Do you remember the graph from the homework yesterday? And I color coordinated it and I said, you know, the domain of green is from here to here, and the domain of blue is from here to here. So the domain of anything with the two of them together is going to be the overlap of their domains, what they have in common. So like if I said, can you plug 2 in blue? And y'all said no, 2 was in green but not in blue. It's the same concept here. So what you just wrote was the input, meaning the inside function. I'm going to highlight it. You don't have to highlight on yours. The inside function, the inside one, has to be included in your domain when you're finding the composition. Okay? So let's look at, we've got F. We've got F of G. I'm going to leave off the of X because we're just talking about domain. Right? The input. What was the input? G. What was the domain for G? It was all real numbers. Yes? Okay. Then you go to your simplified expression for F of G and you find its domain. Go to F of G. Right? What was the domain here? It's going to be, can't be negative, correct? So, radicand greater than or equal to 0 and solve. So, x minus 3 greater than or equal to 0, what does that say? X has to stay greater than or equal to 3. So, we need to find a happy medium, what they have in common between all real numbers and x is greater than or equal to 3. So what is the domain for f of g? It's going to be the most restricted one, which would be x is greater than or equal to 3. It's the same thing as if I said, let me change colors. 1, 2, 3. If I had 3 number lines, this one was G, this one was F of G, so this would be F of G of X, like my final answer, okay? The domain of G, what did we say, was all real numbers. The domain of F of G, we said is what? X is greater than or equal to 3, right? So then my answer for the domain of F of G is going to be just like the graph yesterday. What do they have in common? They have from 3 all the way to infinity. You see that? There's your visual. So the answer to the domain of f of g is that it is bracket on 3 to infinity and beyond. This is the answer. And this is why. This is the visual. Because the input was all real numbers, didn't matter. The entire expression was just x is greater than or equal to 3. So the overlap is that they have x is greater than or equal to 3 in common. Can I plug, this is 3, can I plug 0 into f of g? No, because it's not in the domain of the function right here. If I plug 0 in here, I'm going to get -3 under the square root, and that's a problem. Okay? Could be. Is that cookies? Oh, it is cookies. It can change because of the order. Remember, it's the input function domain that carries over.
But we know that the input of the next one.
So the input of the next one is f, and what's the domain of f? Greater than or equal to 0. Okay, and then now look here, look at the entire function. What's the domain of that entire function? It's still x is greater than or equal to 0. So then when you put it together, it's going to be x is greater than or equal to 0. Yes. I'll leave the little number lines up there if you want to copy that down.
I'm really.
Yeah. So in this particular example, it works out to where it would have been the same thing. But there are going to be examples where you end up, there's a value that you would miss. It's mainly, I think it's the ones with fractions. Like, because then the fraction, there's a number you can't include, but then when we use it in a bigger one, that number disappears, but you still can't include it because it's not in the first domain. Yeah.
What's the difference between f and g and g of f?
This is my thought process to say to myself, what's the domain of g? Just g. This is me saying, what's the domain of just this, right? Okay, and then this is me saying to myself, now put them together. Because because it's a function composition. The domain of the input has to be included in the domain of the composition. So I'm finding the overlap. I'm finding what do they have in common. So this is the two that you're thinking of, and then this is your answer.
Can you give me an example where what we use?
Well, yeah, that's the plan.
Oh, okay, sorry.
Yeah, it's the next one. So I don't know if you heard me. She was asking, wouldn't g of f? What did we say? It was greater than or equal to 0.
That's like what they do the same.
Yeah. So g of f. I'm running out of room. G of f. All right. So what's the domain of f, y'all? It's x is greater than or equal to 0, right? Domain of f. Okay. Now look at the equation g of f. Look at the whole equation. You still only have the square root of x, so you're still going to have a domain of x is greater than or equal to 0. So in this particular case, because they match up exactly, this answer is easier. So the domain of the composition would be that it starts at 0 and runs to infinity after parentheses. The overlap there is that they already match. So there's not much thinking involved. The other one had we had to think. We had to think about, what would be allowed to be plugged in. All right, let's do the next slide, and then let's go. Let's go to the next one. Given that f of x is 1 over x minus 2 and g of x is 5 over x, find f of g, g of f, and the domain. So here's how I arranged it. I said I'll find f of g right here and g of f over here, and then I'll come underneath them and discuss domain. So y'all try it. So for f of g, write function f, right? About the x. So if I beat the x out, now this is where it might help to have a highlighter with your fractions. I'm going to beat the x out by just putting a block right there to myself. Like, okay, there's where x goes, minus 2. You see that? And now in the block, I'm going to put what? I'm going to put 5 over x. This is why the block might be helpful. Because now I can see, I have a fraction within a fraction. This is where you absolutely have got to get comfortable with fractions. That is the answer, but they will not accept it. That's not the correct form. It needs to be cleaned up. You should not have a fraction within a fraction. We've got to combine like terms, get a common denominator, keep, change, flip. Remember all that? Okay. Don't lose me in this thought process. This is 5 over x, right? This is what right here? This is 2 over 1. This is where I would go on my paper. Once I realized what I have in front of me, I would erase the 2, and I would write it in a manner that shows me that it's level with that other fraction. Now I can see that I have 5 over x minus 2 over 1. I need them to have the same denominator, which would be x, right? So now I would change pens. This is what I would do, like on my paper. I would change to a different color so I don't get lost in my pencil. I would change to a different color and say to myself, I need this fraction to be an x in the bottom, so I'm going to multiply by x. And if you recall, you have to multiply by the whatever it is over itself so that you're not technically changing anything. Because this is just a big old fat fancy 1. That's why you can do this. Now I can see this is fixing to have a common denominator. All right? What is it? What would it be if I just multiply straight across? What would that be? That would be, I'm going to kind of like dot it and say that is going to actually be 2x over x. Do y'all see that? x over x. You see that? Now don't you dare cancel the x's out and then say it's 2, because you just undid what we just tried to do, right? So if it does cancel out, that means you did it right. Like, you end up right back at 2. So I'm going to rewrite this 1 over 5 minus x minus 2x over x. Now, do they have the same denominator? Can I combine them? Yes. So I can write them as one fraction all over x. The top would read exactly what you see, which is 5 minus 2x. It really helps to just keep writing. 5 minus 2x over x. When you have a fraction in a division problem, you need to remember keep, change, flip. You're going to keep the numerator as is, which in this case is really nice and pretty. You're going to change the big fraction bar to multiplication, and you're going to take the bottom fraction and flip it.
Flip it real good.
Sorry. And now, what's 1 times anything, y'all? Don't sit here and try to distribute the 1. What's 1 times anything? Itself, right? Don't get so caught up in the semantics of it that you forget you're just multiplying by 1 here. So this crap is just x over 5 minus 2x. The next one's not so bad. Try the next one. You don't want to. But no, you can't, because the 5 doesn't have one. Remember when they have plus and minus signs? It's an entity, and you can't break it apart unless every single thing can lose whatever you're trying to cancel.
Wait, I'm sorry. How'd you get from, how'd you get 1 times x to
Keep, change, flip. Keep the numerator, change it to multiplication, flip the bottom fraction. You never divide fractions. You actually keep, change, flip. Yeah. So you're going to write function g. You're going to beep out the x. I'm going to put my little highlighter, beep. And in the beep, you're going to put what? 1 over x minus 2. Here's another strategy with dealing with fractions. If you have a fraction within a fraction, at some point there is one fraction bar that is like the big one, right? Think of it as a lunch tray, and there's only 2 compartments. You with me? Yeah? A man's brain? Okay. Sorry. This is on top. Exaggerate or make it bold to remind you of what's on bottom, so you don't accidentally think that it's like 5 over 1 over x minus, you know what I mean? You don't want to confuse your fraction bars. One of them is the big one that's separating the lunch tray. Okay? All right. What's nice about this one is we don't have to get a common denominator. We already have, look at it. We had to get a common denominator here because on the bottom we had a fraction minus a whole entity. You cannot keep, change, flip until it's a fraction over a fraction. Look at this. See the difference? So I can go ahead and keep, change, flip because that's a number over a fraction. There's no common denominator needed here. So we're going to keep, change, flip. Keep it, change it, something, so you need to put parentheses around it. Yes, you do. Yep. So 5x minus 10 is the answer. Where'd the 1 go, y'all? It's still there. I don't need to write it because it's understood to be over 1, right? Now let's get to the part that's everyone's favorite. They want the domain of each. Okay. Domain. Here we go. We can do this. First, we're going to find f of g. Then we're going to find g of f. All right. Before I can state the domain of either of those, I need to know the domain of each individual one, right? I'm going to change colors. Coming to f. What type of function is this? It's a fraction, which means there's a number not allowed in the bottom. In this case, you can find it easily by looking at it. What's not allowed to be in there? Careful. You're on G. I'm on F. Oh, yeah. If you set that equal to 0 and solve it, you would get 2. So that means x cannot be 2. Right? All right, come over here to G. What's the domain here? X cannot be 0. Now remember, it's the innermost function, and then it's the entire composition function. And you basically condense those, right? So the innermost one, right here, G, is saying x can't be what? 0. Right? Yes? Okay, and then now f of G, f of G, go over here, go to the end. I'm going to change colors and go back to my writing. We said G, x can't be 0. Now we're going to have to find f of G's domain. Look at it. The only issue is what's in the bottom of the fraction. Take it, set it equal to 0, and solve it. Subtract 5. Divide by -2. You get 5 over 2 or 2.5, right? So this means x can't be 2.5. All right, shaded number line. What's not allowed? 0 and 2.5. Is anything else allowed? Yup, everything. Now, you see it now? Now you're going to write your interval notation. So this is coming from -infinity, skip it over 0. See, this is domain, which means union. 0 to 2.5, and I think they want fractions there. And then 2.5 to infinity. It's, okay, when it's fractions, yeah, because it's just, hey, this number, you gotta skip over this number, skip over that number. When it's the square root, you gotta be careful. That's where you have to actually see, like, okay, what direction am I shading? And then you go with the one that is what they have in common. When it's just fractions, I actually think it's easier because just like we just said, you're just skipping over those numbers. Square roots are harder. All right, what is the domain of G of F? All right, well, carry the domain of F. What is it? Can't be 2. Okay, now let's find the domain of g of f. Go to g of f. What was it? Oh, it's linear, which means it's, okay, so we have our little number line. Don't have to make it too big. We're only skipping over 2, right? I don't know how, but it's already 9:30. Like 9:25. No, the play, I think they got here a little late. His teacher just texted me.
Where's your highlighter thing?
Oh, it's behind me. Where did I put it?